In this video we are going to see about the methods of detecting error. So in the last video we have seen about the types of error, the three types of error: single bit error, multiple bit error, as well as burst error. So in this video we are going to see about the methods of detecting errors when sending the data from the sender to receiver in computer networks, right? So we are going to discuss about the four different methods of finding the errors after the data is been sent from the sender to the receiver. So the first method is known as symbol parity check. Okay, so symbol parity check is a simple error detection method that involves adding an extra bit to the transmission. So it works as 1 is added to the block if it contains odd numbers of ones, and 0 will be added as the parity bit when even number of 1 is present. So we can see the example directly. You can see that sender is going to send the data called as 10011. So the number of ones in this data is 3, right? You can see here 1, 2 and 3. So there are 3 ones. So the number of 1 is 3. So 3 is the odd number, and what I am going to do, I am going to compute the parity bit and I am going to add an extra bit with the data, and this extra bit is known as what? Parity bit. So you can see here 1, 2 and 3. 3 is an odd number, so I am adding 1 here. So after 1 is added as the parity bit, I am going to transmit the data, and this data is going to the receiver. So the receiver is going to see whether the number of ones is even or odd. You can see here now after adding 1, okay, you can see here 1, 2, 3 as well as 4. 4 number of 1 is being present in the data which is received by the receiver. So when it is even, okay, so the receiver is going to accept the data, as well as when the number of ones is not even, it is odd. If it is odd, automatically they are going to reject the data, saying that the transmitted data is error. Okay, so the problem occurs in single bit error is there is a problem. So what is the problem? You can see here the number of 1 is what? 3. So when misplacing 1, okay, so this 0 can be replaced by what? 1, and this 1 can be replaced by 0, right? So the error cannot be found because so 1, this one as well as the last one. So there is 3 numbers, okay. So 3 numbers of 1, the parity bit will be 1, and the receiver says, okay, there is 4 ones and it is even, and I am going to accept the data. So the original message is going to be changed if we are doing calculation like this, right? So the disadvantages is single parity is not able to detect the even number of bit errors. It cannot find even number of bit errors, right? So that was the first problem is the misplacing of 1. The second problem is if the even data is coming to the receiver by any means, right? By misplacing or replacing or anything happens, the receiver is going to accept the data, saying that the received data is even. So we cannot find the error in single parity bit. So in order to avoid this problem, two-dimensional parity check, the second method called as two-dimensional parity check method, is been introduced. So two-dimensional parity check bit are calculated for each rows which is equivalent to the single parity check bit. So the column wise and the row wise data is used to find the new parity bit for each rows and columns, right? When compared to the parity bit calculated on the received data, so receiver end will be assuring the data is correct, right? So you can see here there are 4 bytes of data, right? So you can see here this is the first, this is second, this is third, and this is fourth, right? So these 4 things are going to be added. So you can see here 1, 0, 0 and 0. So there is only 1, and the number is the parity bit will be 1. because odd number of 1 is here. So here also odd number of 1s. So here it is what, even number of 1, so the parity bit will be 0. Here it is odd number, even number, odd number, and odd number here. Three ones are here, so odd number. So this is the column parities, and the row parity will be, you should calculate like this, right? 1, 1, 1 and 1. There are 4 ones, so even parity 0, right? 1, 1, 1 and 1. Even parity 0. 2 ones, okay? 2 ones, 0. So 2 1 0, right? So you are going to calculate the column parity also. So this will also become 0. So this will be added. Okay, you can see here, this will be added with the data, with the original data that I am going to send, right? So the column parity is added here, right? 1 1 0, 1 1 0, 1 1 0, right? So it is been added with the data which is being sent, right? So after sending this, the receiver end is going to check whether the data is original or not by recalculating, okay, the even and odd parity. So this is how the second method, called as two-dimensional parity bit, is going to be worked. So the third one is known as checksum. So here I am going to find the parity by means of calculating the sum of the bit data, right? So checksum error detection is the method used to identify the error in transmitted data, and the process involves dividing the data into equal sized segment and using 1's complement. So I am going to find the 1's complement here. The calculated sum is then sent along with the data to the receiver. At the receiver end, the same process is repeated, and if all zeros are obtained in the sum, it means that the data is incorrect, right? So at the receiver's end, the same process is going to be repeated, and if all zeros are obtained in the sum, it means the data is what? Correct. If the output is not 0, then the data will be what? Incorrect. So the steps involved in checksum. So operation at the sender's end. First, the data is divided into k segments, each of m bits, and the sender end, the segment are divided. The segments are added using 1's complement arithmetic to get the sum. So I am going to find the 1's complement arithmetic to find the sum, and the sum is complemented to check the checksum. So this checksum segment is sent along with the data segment, and the receiver side is going to find whether the arithmetical complemental sum, and the result will be 0. If it is 0, it is going to be accepted, else it is going to be discarded. So you can see the original data 1, 2, 3 and 4, right? So 4 bytes of data is been written here. So the value of k is 4, and 1 contains what? 8 bits. So m is equal to what? 8. So what I am going to do, I am going to add 1 and 2. So what is the output? This is the output. You can see here, after adding 2 bytes of data, you will be getting a carry. So you have to add the carry with the output. You will be getting the result, output result like this, right? So with this result, I am going to add the packet called as 3. So third packet is added to the output of 1 and 2, and you will be getting the output of 3 plus output of 1 and 2 will be what? 1 0 1 0 0 0 0 and 0. So you have to add this output with the fourth byte, right? So you will be getting after adding, you will be getting a carry. So you have to add the carry also. You will be getting the output as 0 0 1 0 0 1 0 1. Now you have to find the complement of the sum, right? That is known as the checksum, right? So while finding the 1's complement, you can see here 0 is converted to 1, 0 is converted to 1, 1 is converted as 0. So 0 0 1 1 1 0 1 as 0 1 and 0. So this is the checksum that I am going to send to the receiver, right? So you can see the output here, right? So after adding all the data at the receiver end, what I am going to do, I am going to add the output, right? I am going to add the output with the checksum. So you can see here the output 0 0 100 101, right? 0 0 100 101 is the output that I am getting. So if there is no error, you will be getting this one, right? So when I get this output has to be added with the checksum, and the checksum is going to give you the sum as all the numbers as 1, right? So when I am finding the complement, automatically all ones will become what? 0. So if the data at the receiver end is 0, what I am going to do? I am going to accept the data, right? So this is how the receiver is going to check whether the data sent from the sender is correct or not, right? So what are the disadvantages of checksum? So if one or more bit of the segment are damaged and the corresponding bit or the bit of the opposite value in the second segment are also damaged, then error happens. Okay, and this cannot be found by means of what? Checksum. So we introduce the next method called as what? Cyclic redundancy check. So in cyclic redundancy check, we are going to divide the value. So there will be a dividend and there will be a divisor in cyclic redundancy check, right? The sequence of redundant bit is known as what? Cyclic redundancy check bit are appended to the end of the data unit so that the resulting data unit become exactly divisible by the divisor, right? So this is the predetermined binary number, and at the destination the incoming data unit is divided by the same number. If at this step there is no remainder, the data unit is assumed to be correct and is therefore accepted. So the remainder indicates that the data unit has been damaged in transit and therefore must be rejected. So now you can see the example how it is going to work, right? So you can see here there is the sender is going to send this data, as well as we are going to divide by means of 1001, right? So there is what? 4 bits. So n minus 1 is equal to what? 3. So you have to add what? 3 bits, 30 bits with the sender bit, right? Now you are going to divide, right? So after dividing, okay, you will be getting 0011. After this we cannot what we cannot do, we cannot divide this, right? So we are going to send the cyclic redundancy check, right? In order to change check, what we have to do, we have to add this value 011 with the sender value. So you can see here 011 is added and I am going to get this as the dividend value. So this is sent to the dividend. Now you are going to divide the same value, divide with the same value 1001, right? So after dividing you will be getting the answer as what? Zeros. If it is 0, then the receiver is going to accept the data is correct. If it is not 0, if 1 comes in the output, automatically the receiver is going to find there is an error in the packet that is sent from the sender to the receiver, right? So these are the 4 different methods of finding error in computer network. So the first method is known as what? Single parity check, where we are going to add only one parity bit by means of odd parity, by finding the odd parity and even parity. So in the second method is known as two-dimensional parity. We are going to find the column as well as row parities and we are going to send the data. In checksum, we are going to add all the packets together and we are going to find the complement, and if the value, complement value is 0, the receiver is going to accept the data. If the value is not 0, then the receiver is going to reject the data or discard the data. And the last method is known as cyclic redundancy check. Here we are going to divide the bits and we are going to add the remainder with the data bits and we are going to get the output as 0. If the value is 0, the receiver is going to accept, and if it is not 0, they are going to discard or reject the packet that is sent from the sender, right? So these are the 4 different methods of error detection. That's all for this video. Thank you.